Hi, my name is Michael Benben, and I am in Calculus 2000 for Challenge 2016. Today I'll be going over a couple questions that we were assigned. First, I'll be going over number 32 from chapter 5.4. So here we have to find the definite integral of dx over 1 plus 4x squared from 0 to 1 over radical 3. So that here in black is the original problem, and we're going to move on to the blue. So this question requires us to use u substitution, which derives from the chain rule. So here u is going to be equal to 2x, because here we have 4x squared, which is the same as saying 2x squared. And we're going to do this because once we derive u and plug it back in, we'll see that 1 over 1 plus u squared is the derivative of arctangent. So now when we integrate it, it'll help us get to arctangent and therefore be able to answer the question. But first we're going to go on here into the green. I rewrote it to make it look nicer. The du over 2, that 1/2 will move to the front, and we'll have the same integral with only the function that we're going to be integrating. And then in the red we have 1/2 and then the integral of 1 over 1 plus u squared, which is arctangent of u, from 0 to 1 over radical 3. And then with the u, we're now going to plug back in the original 2x that we have for u here. And this is one of two ways that you can solve this problem. So this is the way that I chose to do it, but while remaining with the same interval from 0 to 1 over radical 3. So now here in black, we're going to take this and continue solving the problem. Now that we're at this point, we're going to continue here again to the blue, where we're going to plug in the limits of the integral. So we have 1/2 times the arctangent of 2 times 1 over radical 3, which is the upper limit, minus the arctangent of 2 times 0, which is the lower limit. So then when we continue, we're going to find that we have to get the arctangent of 2 radical 3 over 3 minus the arctangent of 0. The arctangent of 0 is 0, and the arctangent of 2 radical 3 over 3 would give us a number that is a decimal. So we're going to leave it like this to keep it in exact terms. And now I'm going to rewrite it as our final answer. So here our final answer for number 32 in section 5.4 is the integral from 0 to 1 over radical 3 of dx over 1 plus 4x squared is equal to 1/2 of the arc times the arctangent of 2 radical 3 over 3. Now for the next question, we're going to take a look at chapter 5.6, where we're going to do question number 101. And we're asked to find the area A of the region between the curve y is equal to 3x over 1 plus x squared and the interval -2 is less than or equal to x is less than or equal to 2 of the x-axis. Now, what this graph looks like, it looks a little bit like what I have drawn here. So if we find the interval from -2 to 2, we're going to end up getting 0 because the same area is here in the negative area as it is in the positive area. So we're going to split that up and make an integral to find the area underneath one of them, and then multiply that by 2. So here we're going to find the interval from 0 to the integral from 0 to 2 of this function, and then multiply that by 2 in order to get the final answer. Alright, now we're going to continue by taking a look at the integral to find the area under this curve. So the curve 3x over 1 plus x squared, we're going to find the curve from 0 to 2 and multiply that by 2 in order to get the total area between the x-axis and this function. Since if we were to just find the integral from -2 to 2, as I mentioned before, we would just end up getting a value of 0. So first, we're going to take this and we're going to write it a bit better. We're going to take this 3 from the numerator and multiply it out to the front. So we're going to end up having 6 times the integral from 0 to 2 of x over 1 plus x squared. So from here, we need to implement the u substitution method in order to integrate. So for u, we're going to use 1 plus x squared. And when we derive that, we get du is equal to 2x dx. And solving for dx, in order to plug it back into the integral, we get du over 2x. So with this integral right here, we have 6 times the integral from 0 to 2 of x over u now, times du over 2x. The two x's are going to cross out, and this 1/2 that we just added into it is going to also be multiplied out to the front. So we end up with what we have here in red, which is 3 times the integral from 0 to 2 of 1 over u du. And now we're going to move on and actually integrate this and find the answer. After going through u substitution, we now have an integral that we can integrate. So first, we see that the integral of 1 over u is equal to the natural log of u. So we have 3 times the natural log of u in the interval 0 to 2. We're going to take this, and now we have to replace this u for what it originally was, as we wrote down before. So we're going to rewrite it to have 3 times the natural log of 1 plus x squared from the interval from 0 to 2. Then we can plug in those intervals, having what we have here in green, and when we write it all out, we end up with 3 times the natural log of 5 minus the natural log of 1. Now, the natural log of 1 is 0, so in the end, our final answer is going to be 3 times the natural log of 5. Once again, the final answers for these two questions are for number 32 of 5.4, 1/2 arctangent of 2 radical 3 over 3, and for chapter 5.6, number 101, the answer is 3 natural log of 5. That'll be it for this video, and I will see you in the next one.